My name is Michael Dre. I'm the Technical Operations Manager for the Cal State LA Hydrogen Research and Fueling Facility. I've been here for about 7 years. Well, here at Cal State LA Hydrogen, what we do is we produce hydrogen to demonstrate and to actually perform fueling of light-duty cars which operate on what are called fuel cells. Fuel cells are devices that can convert hydrogen into electricity to power these vehicles. So these are electric vehicles, but rather than charge them by plugging them into a wall, you fill them with hydrogen gas under high pressure, and this is later used by the vehicles to produce onboard electricity. To produce the hydrogen here on site, we use a technique known as electrolysis. What we do is we take water in an aqueous solution of potassium hydroxide, and we introduce direct current from renewable energy sources such as solar or wind. And when we do that, that creates the separation of the hydrogen from the oxygen on the water molecules. This hydrogen we collect, the oxygen is just jettisoned to atmosphere, but the hydrogen, we collect it, we compress it, store it, chill it, and dispense it into these vehicles at about 12,000 pounds per square inch. This high pressure is necessary to get any real mass or weight of hydrogen in the fuel tanks of the vehicles. Well, this station the planning for this station began in the early 2000s. It was the idea of one of the faculty here in the technology department. It was planned to be operational in 2010. It took 3 years longer than that to get it operational. It did not function properly as built by the general contractors. So the university took the project over. We had it running by 2014. At that time, we were the first station in the world certified by a weights and measures agency to sell hydrogen to the public by the kilogram. So that was one of our big accomplishments. At the time, we were in a race with the Germans to meet that milestone. And so that's kind of one of our claims to fame. But we are the largest hydrogen station located on a university in the United States. There are other stations operated that are bigger than ours by universities, but they're not actually on the campuses, and they don't operate them either. But here we actually train engineering students how these plants function and how to maintain them and operate them. This station was built with funding provided by the U.S. Department of Energy, the local South Coast Air Quality Management District, in other words, our air pollution agencies, along with the California Air Resources Board, which is the largest environmental agency in the entire world. They donated $2.7 million to prove that this technology could work. The distinction between hydrogen fuel cell electric vehicles, or FCEVs, and battery electric vehicles that you plug in to charge them up, like the Tesla, those are called BEVs. The hydrogen, with hydrogen, we're able to fuel the cars much more quickly, to give them their potential energy much faster, in 8 to 10 minutes. Some fueling stations can do it as quickly as 5 minutes. This is in contrast to sometimes hours that it takes to recharge a battery electric vehicle. So that's the principal advantage of the fueling times. They're also designed to get extended ranges, a little bit further ranges than a typical battery electric. These cars get about 350, even 380 miles on one fueling event, which takes about 5 to 6, 8 minutes. Most of these vehicles on the market at the moment, there are cars offered by Toyota, the Toyota Mirai, there's the Hyundai Nexo, and the Honda Clarity. They typically get about 50 to 60 miles range on 1 kilogram of hydrogen. 1 kilogram of gaseous hydrogen weighs about 2.2 pounds. And it has nearly the same energy equivalency of 1 gallon of gasoline. Well, battery electric vehicles, these are all plug-in vehicles or hydrogen vehicles. They're both electric drive vehicles, and they both produce zero emissions at the point of use. Of course, if you charge an electric car at a charging station with a plug-in, that electricity is the product of wherever it was made. It could have been made from a gas plant, a coal-burning power plant, nuclear, or could be renewable as well. That technology, those fueling stations are much easier to charge and to manage. Imagine you're just plugging in the vehicle, right? So that's a much simpler proposition than what we do with a hydrogen. A hydrogen takes a more complex fueling station. If you're producing the hydrogen on site like we are, in contrast, most stations do not do it the way that we do it. Most of them produce their fuel from natural gas and then transport the hydrogen to the fueling stations where it's dispensed into the cars. But these stations are rather complicated and expensive. They're hard to maintain. We're making improvements all the time, but an average fueling station now for hydrogen costs about $2 million. This station, we have about $5 million in this station. Well, we talked a minute about the differences between battery electric vehicles and hydrogen fuel cell vehicles in the charging times. These vehicles can be charged much more quickly by filling them with hydrogen, which is later again converted into electricity on demand by the driver when he or she steps on the fuel pedal. There is an energy loss associated with the production of hydrogen, however. Anytime you transform energy from one form into the other, such as our taking of electrical energy and converting it into hydrogen, we lose up to 40%, 50% of that energy. Then across the fuel cell of the vehicle, there are also energy losses. So that makes the hydrogen cost proposition a little bit higher for now. It typically costs us about $8 at this station to make 1 kilogram of hydrogen, which will propel a vehicle, an average vehicle, maybe 50 to 60 miles. So this is still pretty expensive technology. The only way that this is going to improve is with scale. Once larger stations are built, also there need to be improvements in the efficiencies of the electrolyzers and really pretty much all the components, compressors, fittings, everything from fittings to valves to hoses. All this technology needs to evolve and improve over time. So I think the hope is that it will. Right now the tendency seems to be towards more applications for medium and heavy duty applications, such as fleets of trucks, applications at the ports for forklifts and warehouses, forklift operations. There are plans, lots of folks building things like shuttle buses. But to give you a cost comparison, a natural gas bus might come in at $500,000, less than that probably. Hydrogen bus right now is probably over $1 million. So the technology, because it's not widely deployed yet, it's still rather expensive. It seems that the battery electric vehicles are winning the race at the moment. There are many more of those deployed. They're easier to deploy, they're cheaper to build, cheaper to maintain. There are currently 8,000 only fuel cell electric hydrogen cars in California. That's not very many cars, 8,000 compared to 35 million or so in the entire state. So at the moment, you'll read about manufacturer plans to expand the availability of these hydrogen vehicles, but much is going to depend on the deployment of the hydrogen fueling stations, which take longer than they initially thought to build. I can see it in the future as being a viable alternative. It's one that I think the government has largely supported for years to keep it as an option. I think that there's a long way to go, though. There's a long way to go in improving the technology of the stations, improving the technology of the cars, streamlining the permitting and the building of these hydrogen fueling stations. Of across the country and lots of other challenges. So remember, it took 100 years to build our current gasoline-based fueling infrastructure. Imagine the thousands and thousands of stations that exist across the country. So in my opinion, I think it's a viable technical alternative, but we're not going to just shut down our gasoline stations and our diesel stations in the next 5 to 10 years. It's not going to happen. My opinion, it will take decades.